Alrighty, when we're adding and subtracting radical expressions, I want you to keep in mind that the radical expressions are kind of like x's or y's. They have to be exactly alike in order to add. Just like you can't add x's to y's, you can't add a square root of 3 to a square root of 4. Those don't mix. So in this case, you have 7 square roots of 11 plus 6 more square roots of 11. So since the square root of 11s match exactly with the root and the value inside, which is called the radicand, since you have 7 of them and 6 more of them, you can add them together to be 13 of them. Kind of like if you had 7 x's and 6 x's, that would give you 13 x's. Since both radicals are identical, you can add or subtract them. So in this case, if you have 7 square root of 2's and 8 more square root of 2's, you have 15 square root of 2's. Let's look at this. You have x cube roots of 5 minus 4x cube roots of 5. So you have negative 3x cube roots of 5. So it's x minus 4x were able to be combined because they're multiplied by the same radical. So let's look at this. What if the radicals don't match exactly, but they're not simplified? So what's key here is that the radicals do need to be simplified before you can decide whether or not you're adding or subtracting. So here I'm going to simplify my radical and see what it turns out to be. I simplified both of the radicals, and I end up getting 7. I pulled out a 3. Here I pulled out a 2, and there was already a 5, so you have to multiply it. And look, I end up getting 21 square roots of 2 and 10 square roots of 2 just by simplifying the radicals. So I had to do that first. Once I simplified the radicals, now I see, well, I've got 21 of them and 10 more of them. I can combine them together. So let's look at another example. And here are the directions. You simplify the radicals first, pull out any of the roots that you can pull out. Then you combine all your like terms using your coefficients as long as the radicals are identical. So here I'm going to simplify the radical. The x can't be simplified, so it's going to stay underneath. So is this 3. The x can't be simplified. It's going to stay underneath. So is this 3. But I got to pull out a 3 here to multiply by the 4. And I pulled out a 2 to multiply by the negative 8. So this becomes 12 square root of 3x, negative 16 square root of 3x. These match. So 12 minus 16 is negative 4. All right, let's try a few. Okay, here are those same worked out. It's the same radicals to see if you can simplify them. Again, you needed to simplify them first, then determine if you can combine them. We simplify them by factoring out any of the roots we can, and then we determine, hey, we can simplify these. But then when we look at this one, a square root of 5 and a square root of 2 do not match. So you cannot simplify this. You can't do any more than what's already being done. Let's talk about how to multiply radical expressions. So we've added and subtracted them. Now let's multiply. You can multiply radical expressions because you can multiply any number times any other number, whether it's a variable, a number, a radical, it doesn't matter. So multiplying and dividing don't have the same rules as adding and subtracting. You're going to use the same kind of method that you used before, whether it's FOIL, distribution, or the box method, depending on how many you have. So this first example has a radical multiplied by a binomial, right? It has 2 parts to it. Now these are being added together, not multiplied. So because there's an addition in here, you have to actually distribute, right? If these were multiplied by each other, you would just have x times the square root of 7 times the square root of 2, which would be x times the square root of 14, right? But these are being added, not multiplied. So you distribute it just like you would anything. Keep in mind that radicals are always listed last. When you're multiplying things together, the radical is the last part. There's a coefficient or a variable, it goes first. So we have x roots of 7, and then we have the square root of 7 and 2, both under the square root, so they become the square root of 14. And that's as best as you can get here because you can't simplify this anymore. They don't match, so you can't add anything. What about the cube root? Well, you do the cube root the same way. A cube root is distributed just like a square root. Since both of these are cube roots, you can combine them under the radical. Both of these are cube roots. You can combine them under the radical. And then you notice, hey, I'm looking for a set of 3, and there's actually 3 x's in here, so I can pull the x out. You can also use FOIL, especially if you have a binomial times a binomial. So FOIL, remember, stands for first, the 2 first terms, outside, which are the outside terms on the very edges, so these 2. Inside is the purple part, the 2 inside terms are multiplied, and then the last. Now you can do them in any order you want to, you just need to make sure that every term is multiplied by every other term. This acronym just keeps track of that you're not duplicating something or that you didn't forget something. So now that I have these terms that were multiplied, I start simplifying them. Well, I remember that the square root of 4 is 2, so 20 times 2 is simply 40. This can't be simplified, this can't be simplified. I notice that the square root of 9 is 3, so I go ahead and multiply that out and I get negative 18. Now I need to combine all these terms, right? So this term is equal to that, so I rewrite it. These 2 middle terms I rewrite, and then the last term I rewrite. So can I combine anything here? Sure. I got the 40 and the negative 18 to give me positive 22. I've got negative 15 square roots of 6 and 8 square roots of 6. These square roots of 6 match. That means my coefficients can be added or subtracted in this case to give me this. Now try the last one. Remember that anything squared means that times itself, even if it's a binomial. So we would rewrite it, and then we would FOIL it out, simplify, combine like terms, and this would be your answer. You typically write the real part before any irrational or radicals or anything like that. So typically the 10 would be written first, even though it's being added, and then anything with a radical would be second.